That is user graphics interface, and second is a output window. Second is a output window, right? So already we have gone through. This is the top one is utility. This is the main menu of the Ansys. This is the graphics. On the left hand side, you have a graphics toolbar, and on bottom you have a entity toolbar where you can find out which material you are using or type of material, type of element is there, which is a real constant is there, okay, which type of coordinate system is there, right? So going to the main menu where you have a three main step: preprocessor, solution, which is also called as a processing, and general post processor, okay. Now solution, in preference we use a structural preference. Our aim is to find out a stress, how you get the stress by you knowing the strain, and how you get the strain by knowing the change in length, okay. So that are the dependent, or in case of dynamics mechanics, you have to find out change in length. From that you can find out strain, that is a change in length to the original length, and by knowing the material property as a Young modulus you can find out the stress. So that is the ultimately aim is. So maximum trace to the nominal trace is a trace concentration factor. So by knowing the trace value, we are going to calculate what is a stress concentration factor, okay. So my preference is static structural. Now before going to that, let assume a certain type of problem. Suppose you have plate, right? This is your geometry, right? And this is the hole is there, right? We will assume certain dimension. Suppose this is suppose 250, okay, of height, 250 of width, and thickness is suppose 5 mm for the plate. Thickness is a 5 mm, okay. And this hole have, sorry, this is a 250, not 500. Rectangular plate is there, exactly rectangular plate is there, and we will use this diameter as a 50 mm. We use a hole with a diameter of 50 mm, so it will create the discontinuity. Here we apply the force, P, and here we constrain the plate, so this is the general type of problem: plate with a center hole. Dimension you can take by your own feasibility, right? So for that we are using the 2D type of element. Which is generally the chord in nature, which is having a 1, 2, 3 and 4 nodes, okay. A chord element, okay. 2D element, it is a area element, okay. Hope you get the problem. Plate I applied 250 by 250, right, and thickness of 5 mm, where the P is a load value. So either you can apply the load or pressure, no problem. Our aim is to subject that plate to the tensile forces, right? The nature of the force is tensile in nature, right? Where E we use for the steel, and that is again 200 gigapascal, 200 gigapascal, or which is equal to 200 into 10 raised to 3 megapascal, or which is equivalent to 2 into 10 raised to 5 megapascal. 2 into 10 raised to 5 megapascal, okay. So this is the type of problem we are tackling. And we assume certain value of P, so which will be applied the positive value, so it will be create a tensile force, okay. So for that, first is step is element type. So go to the element type, add element, right? Not define it is showing. So add element, it will open the element library. From there you have to select the solid and 4 noded 182, that is a quadratic element. It's in the form of quadrilateral triangle, quadratic element, okay, right? So plane 182 is selected. Here The name is different, right? So plane, it is called as a area element. Plane is called as a area element, and which will only support the load in that plane where the your element is located. XY प्लेन मध्ये जर असेल इलेमेंट तर त्या XY प्लेन मध्येच लोड ऍक्ट होईल तुमचा, राईट. Perpendicular to that plane, it will not support any load. Perpendicular to that, it will not support any load. That is the meaning of plane 182. Okay. Now go to the option, right? Element behavior you have to choose. Element behavior you have to choose. So it is not a plane trace problem, it is not axisymmetric problem. So we are using plane trace with thickness because we have a certain thickness for our plate, 5 mm. Okay, so plate with a thickness, you have to choose that element behavior. You know where you are going, you are clicking on the option, right? Plate with plane stress with thickness, that is the short form, plane stress with साठी wi and oblique thickness. So that behavior you have to select. Okay, close. Now go to the real constant, add properties. That is the, what is the real constant? In last practical I have told that is the geometric input to the FES software. What is the real constant here? Anyone? For 2D problem, geometry is 2D. What is the real constant? Yes, anyone? What is the real constant for the 2D problem? Anyone? So it is thickness. It is a thickness as a real constant. Okay, so thickness value किती आहे? 5 mm. So simply in case of thickness that is indicated with the THK, you have to mention the value 5 mm. Click on OK, right? So set 1 is defined. Set 1 belong to the real constant, right? Previously it is showing not defined. When you input the thickness, automatically it will take the value 1, that is set 1, or it is a corresponding to first value whatever you have defined, that is the real one. Okay, that is the thickness. Close. Go to the material property again. In material property, go to the material models, right? Under that structural, linear, right? Which type of analysis you are doing? Linear. Structural in linear. You are also non-linear, density, thermal expansion in case of thermal analysis. Under that linear, the material behavior is a elastic. Under elastic, my material will be isotropic. That is same property in every direction, right? So it is only asking the one value of E, that is E stands for Young modulus. So it is a representation of X, that is Ex in any direction you can say. That is only one value that will be same in all sense, same directions, and PR is a Poisson's ratio in that plane, XY plane. So it is a 0.3. Click on OK. So it will show the material model number 1 is created, which is a linear isotropic material. Linear isotropic material. Okay. Then once you done the material property, then you go to the modeling, right? Now this is very important, how you model that. Okay, so till now you can save db. So click on save db button, right? In between, whenever you complete the every stage, you have to click on save db. Okay, now go to the creation of area. So create area. Okay, my area is a rectangular in nature by 2 corners. Okay, rectangular area, right? So I will consider the origin at 0 0. Okay, and I will give the width and height. So 0 0, that is the origin work plane, you can say that, x coordinate, y coordinate. Width is 250, height is 250. Okay, when we apply OK, so it will create the area, rectangular plate create केली त्याला, बरोबर आहे? Hope you are getting this, right? Where you have gone in modeling, you have gone to the create a rectangle area, right? Now this is you observe the various planes, right? It will look like राईट. तुम्हाला एक काय दिसते, एक लाईन दिसते, बरोबर आहे. आणि त्या लाईनला एक्सट्रूड केल्यानंतर तुम्हाला काय दिसतील, एरिया दिसेल. सो दिस इज हॅव्हिंग अ झिरो थिकनेस. This is having a zero thickness. When and you observe its location will be exactly on xy. Okay, xy plane. xy plane मध्ये असेल, which is a zero thickness. So whatever the 5 mm input you have given, that will be taken half above and half below, or half on one side, half on the other side. Okay, half on one side, half on the other side. All right. So this is the area created. Now you can go to the plot control and you can on the numbering. Okay, plot control मध्ये कुठे third tab is there, numbering. You will click on numbering and you can click on area number on. Area number is there, third option. So you can click that on. Okay. Okay. So as you observe, the A1 is created. By default, the area is 1. By default, area is 1. Okay. Now I have to create the hole. So for that purpose, again I have to create the area circle. Solid circle is there, right? Now I have to select where the circle location is there, at the exactly center, right? Center la ek location hai. So while inputting the coordinate, I have to consider as x as a 125, y as a 125. So its location will be exactly at the center. Okay. And what is the diameter of the hole? Diameter of hole is 50 mm. So here the radius is asking. So radius is a 25. Radius is a 25. Okay. So where the plane you have selected, origin of that circle or center of that circle is selected at the center of the plate. So that's why we have inputted it has a 125, 125 and 25. You click on OK, right? Now you observe the A2 is created. Area 2 is created. Initially, what is the your area A1? It is a rectangular. Now what is the area A2? Area A2 is circle. Area A2 is circle. So you can click on a power graph. Okay. So you can observe the area A1 and A2 are being created, and these both are the solid area, right? Now go to, now to create the hole, I have to subtract area 2, that is circular area, from this rectangular area, right? So this is again one of the important step, how to apply the booleans operation or subtract operation. Okay. So in modeling, the second tab is there, operate is there. Okay, go to the operate, right? Use the booleans, right? Click on subtract, click on subtract. Okay, operate. Under operate, the third option is booleans. Under booleans, again third option is there is a add is, subtract is there, divide is there, glue is there. So addition of area, subtraction of area, volume, line, whatever is there. Divide is division of area into equal part or uneven parts. Glue is stick the area. म्हणजे दोन वेगवेगळे एरिया आहेत, तुम्हाला एक ऍड करून तिसरा एरिया जनरेट करायचा आहे, तो ऑटोमॅटिकली तो ग्लू करेल, ऍडिशन करेल, राईट. सो subtract now areas. Okay, now this is again one important step. Now pick or enter whatever the at the bottom it is showing, pick or enter the base area from which you want to subtract. Now which is your base area? My base area is a rectangle. My base area is a rectangle. Okay, so go to the areas, select the area. So this is by default it is selecting. So select until that the plate is not being selected. Okay, now this is your plate is selected, area number 1 is selected, it is showing. Okay, so select the area number 1, select the area number 1. Okay, click on apply. Now again it is actually asking pick or enter areas to be subtracted. Ata which area you have to input? We have to give the input area A2. Okay, again it is area 1 is selected. So you, or you simply you can consider the here Okay, I will again repeat this. Right, subtract areas. Right, select the area A1. Right, there are two areas at this location. So it is showing that you have picked the area 1. Okay, so your option is correct. Then select the OK. Then click on apply. Right, now again it will ask to select enter the area to be subtracted. So select the area A2. Right, so again it is showing that there are two areas at this location and it is picking the area. So go to the next. So automatically now you can show in the violet color, that is area 2 is selected. Okay, area 2 is selected. Click on OK. Just click on OK, apply. Right, now area A3 is created. Right, initially it is showing the blue. Right, whatever the area is there. Now this is the discontinuity. That's why it is showing with the red color. And once you create subtract area 1 minus area 2, the new area is created, and that area is called as the A3. That area is called as the A3. So this is the modeling. So in modeling you have to I first create the two areas, and in second option, in operate you have to use the boolean operation to subtract the area A1 minus area A2. So it will create the area A3. Okay, area A3. Right, now go to the meshing. Go to the meshing. Mesh tool is there. Mesh tool is there. Now you have to select the mesh the area. So go to the size control in area set. Right, now this is area is there. So A3 you have selected, area number 3 is selected. There is only one area present now, because you have subtracted the area and the new entity is generated. It's in the form of area with a discontinuity. Okay, now this is the area number 3 and it is only one area now for this graphics. So apply. Now you can select the edge length 10 mm. म्हणजे इलेमेंटची एज लेंथ काय कन्सिडर केली आपण 10 कन्सिडर केली. सपोज दिस इज इलेमेंट इज देअर. राईट, हा इलेमेंट आहे तुमचा. राईट, बॉटम राईट कॉर्नरला. तर 1 to 2 नोड मधलं डिस्टन्स 10 mm असेल मिनिमम. पॉसिबल केस इज देअर. राईट, क्लिक ऑन रीड्स हिडन. राईट, now element edge size is edge length is selected as a 10 mm. Click on OK. Right, now here area is there. Okay, right, so use the quad and use the pre-mesh. Right, I will explain how to create a map mesh using the dividation of area in next practical. Right, so create already there is a automatically mesh area will be displayed here in a mesh. So you have to use the quad element, use the pre-mesh, click on mesh, select the area, click on OK. Okay, now what is the error is displayed, warning is displayed, not error. You can read that the mesh of area E3 contain plane 182 plane 182 triangles. Okay, what initially our element is plane 182 quadratic, but it is showing that the mesh of area 3 contains plane 182 triangles which are much steep in bending. Use quadratic 6 node or 8 node element if possible. Okay, ठीक है. So what is the meaning of that? You have only selected the quad element, but you can observe here at this location there is a triangular element is created. Okay, also you can observe here. Right, again the triangular element is created. So sum of the 2 to 3 elements that are created that are triangular in nature. Okay, आता तुम्ही जर बघायला इथं 1 2 दोन एलिमेंट सध्या आहेत. ओके, and you observe near the vicinity of the hole mesh is irregular. So this is a low quality mesh. Mesh is irregular, so this is a low quality mesh. Okay, low quality mesh is there. So you observe away from the hole or at the corner the mesh is regular. The mesh is regular, but mesh is regular, but at the vicinity or due to this hole. So it is taking nearer the hole. The first layer is a regular meshing which is quadratic in nature, but around to adjust, right, near the vicinity, it will changing the color. Somewhere the rhombus are there, you observe the rhombus are there, right, or it is a diamond like shapes are there somewhere. Okay, so this you can observe. So this is due to the discontinuity. So by default we kept this as a meshing because we are only doing the first trial. Okay, then go to the loads, right, define load, apply structural. Under structural you have to apply the displacement on lines. Okay, now you have to select the left hand line, click on apply. Now you observe there is only plane problem is there. So it will be only 2 degree of freedom is there, x ux and uy. Generally 2D element have a 6 degree of freedom, but this is the plane problem, right? Plane 182 element is there because we on the thickness behavior. So that's why it is only considering the 2 degree of freedom. So all degree of freedoms you can select, and displacement value will be 0. Okay, click on OK. So this edge is constrained, or it is held as a fix left side of the plate. Okay, then go to the again structural. So you can apply the force, no problem, but to apply the uniform load we use the pressure on again line. So select the right hand line. कुठली line select करायचे? We have to select the right hand line, apply. Now it is asking the pressure value. So pressure value is suppose so pressure act normal, right? So to act a tensile pressure you have to use the negative. Suppose 5 megapascal pressure आपण apply केलं, right? Okay, now you can observe -5 meanings is opposite direction. म्हणजेच काय, don't confuse between the point load and pressure act always normal on a surface. Normal to the surface म्हणजे towards the area, but I have to you have to consider the problem that is plate with center hole and it is subjected to tensile forces. That's why we have reversed the direction. That's why we have given the negative sign. Okay, right? So this is the first step is done. Now go to the solution, go to the solve current ls. Okay, it is generally showing a problem dimensionality. Okay, so solution is done, the option will be appear. So here you can observe problem dimensionality is a 2D. Okay, degree of freedom are only 2, ux and uy. Then you have analysis type is static structural, right? Global symmetric matrix is global assembly of matrices is symmetric, right? Load step is 1. Whatever the 5 megapascal load is applied, that is taken at a single instant. Okay, so that is the solution option is there. Similarly, you can go to the output window. You can observe here, right? Whatever the file has created, so you can observe the number of elements somewhere here. Then you create the meshing. Here the load is value. You can observe the 5 megapascal load is applied. Before that, there we have done the meshing. So you can observe here maximum number of area mesh is 1. Number of nodes are created are 671, and number of elements are created 614. Okay, so you can observe how many elements, how many nodes being created. Okay, so whatever you are doing, that is recorded in output window. Okay, so now we are going to the general processing. Plot result. Okay, plot results, you have to control plot, nodal solution, displacement reduce DOF solution, displacement vector sum. Click on apply. Okay, right? So you can observe this is going for the, as you saw, the circle shape काय झाला, it is taking the form of ellipse because we have pulled that plate. Okay, so you can animate A N C and TR in short form. So you can observe how the circle is being going to deform as an ellipse when you apply the load, right? You can observe here on the left hand side. I will stop that. On the left hand side you can observe the edge is fixed and the value is minimum. The value is minimum. So zero deformation is there at this end, and the right hand side is subjected to maximum deformation. Okay, the value may be minimum. We are don't bother about the values, right? Again, we can go to the element solution, stress value, right? Go to the von Mises. Why we are taking the von Mises? Theories of failure accurately predict the or using theory of Philipper, you have one Mises stress theory. So one Mises stress theory accurately predict the behavior or failure of the component or value of stress. So that's why it is taken as a one Mises value. Click on OK, right? Now you can observe minimum value is at this location. It is 1.5 megapascal and maximum value is 14. Now you can observe here the location of maximum trace, where the location of maximum trace is there at the minimum cross section. This is the resisting cross section when the load is applied, which is a tensile in nature. So blue indicate the minimum and red indicate the maximum. So you can apply the more load, the plate is going to more deform, the value of trace may be a more. Okay,